Okay, we're going to look at a couple different lenses and see how the focal length of the lens affects the field of view for the camera. So in this case we're using the Baumer Verisense software, and you can see an image here. This is a live image of a hotel card. Right now we're using an 8mm lens. So each lens has a focal length. In this case it's 8mm. That's a pretty standard size. You have 12, 16mm, and then they get higher. The other lens I have here is a 35mm lens. So I'm going to show you how the field of view gets affected. So in this case it's an 8mm lens, and so we can see the whole key. It's kind of zoomed out. The higher the focal length, so if I go from 8mm to 35mm, it's a bigger number. We're going to be more zoomed in. Of course, this doesn't affect the number of pixels in our image, because inside the camera the number of pixels never changes. It's still the same on the sensor. It's just that our field of view is going to be more zoomed in with the bigger lens. So each pixel will correlate to a smaller actual world dimension. So, okay, you can see this is an 8mm lens. I'm going to unscrew that from the camera, and leaving the camera at the same height, I'm going to now use this 35mm lens. Okay, that's almost screwed on there. And now I'm just going to focus that. So that's out of focus. So yeah. So you can see how that. Okay, now it's in focus. You can see how zoomed in that is with the 35mm compared to the 8mm. I mean, we have, in the other instance, maybe we could have 2 or 3 keys fill up the entire field of view. In this case, we have just one key here, maybe 2 inches wide, and it's filling up more than the field of view. So, and that's what I was saying. This is an example of that the higher the focal length, in this case 35mm, the more zoomed in you are. So if we threw on a 50mm lens, for instance, we'd be even more zoomed in than this. Again, the camera stays at the same distance away from the object, but by changing the lens you can zoom in or out on that object.